So good morning everyone and welcome to your channel Learn Data Science with Pranjal. So this would be the sixth video on the time series and probably the last, or maybe I might add one more video. So in this video, basically we will see we will do our Python coding on time series, how to build the model ARIMA, SARIMA or SARIMAX model, and how to determine the values of P, D and Q. So the theory part took long time or took many videos, but if you notice with the advance of the libraries in the Python, model building, the time series model building would be very easy, very easy over here. So before model building, I will also show you if you want to see if you want to plot your ACF and PACF. So in this video, the dataset which I am taking is coming from my third video, in which I have taken the air passenger dataset. So if I just go up, this was my dataset. We had a month, we had a passengers, and then how do I? So please watch that video and then you will understand that dataset. So, but over here, I'm not explaining that dataset. My main aim is to see how to build our ACF and PACF, which we have discussed in the previous video. So DF1 is my data frame, and I am importing PACF, plot ACF and plot PACF. And then if I say plot ACF, DF1, and if I say lag is equal to 40. So it will plot the graphs for my 40 lag. So lag of original time series with your lag 1, original time series with your lag 2, so on and so forth. Similarly, plot PACF and over here. So let's say from this graph, we do not get any meaning because the values are decreasing very gradually. And over here, after my second lag, if you notice, the correlation has gone down almost to 0. So these plots are for your own understanding. But when you are building a time series model, you don't have to manually look into these graphs, because you would be using a function and that function will automatically calculate all these values and it will let you know. So you can directly use those values, and normally we do the same thing. But if you understand how the values are calculated, it's good for you and it gives you in-depth understanding. So we are going to build a model on this dataset. The name of that dataset is restaurant visitors. So this is a very common dataset and it is easily available on your many open websites. So I have downloaded from them. Probably it is available on your Kaggle as well. So restaurant visitor datasets, let's quickly do the understanding what this dataset is. Over here you have a date column. You have a column weekend, you have a column holidays. So holidays are denoted, whenever it is a holiday, it is marked as 1. And if it's not a holiday, obviously it is represented as 0. So you will say most of them are zeros and few ones you would be getting. And then you have a holiday name. So we are not much interested in holiday name because we are interested whether it's a holiday or not. And what's the reason behind the holiday, we are not much interested. Then you have rest 1, rest 2, rest 3, rest 4. So these indicates the restaurant. So consider a restaurant and it has 4 different outlets in a city. And these are the number of people or the number of visitors to that restaurant. And you can say in 100. So when I say 65, it's 6,500. And total is, if you add the values of column J, K, L and M, you get the value of n. So basically, what if you want, you can do the individual forecasting for a different restaurants. But what I will do is I will do the forecasting on the total column. Okay. Now, if you notice, whenever the holiday comes, so for example, let me take a holiday. So for example, let's say this Tuesday, it was a holiday and the number of people were 100. If I compare it with the previous Tuesday, you notice that number of visitors were 76. And if I compare with, if I take another some holiday, uh, so let's say this Thursday, it's St. Patrick's Day, number of visitors were 209. But if you notice, the previous Thursday, the value was only 102. And if you go for the next Thursday, the value is 126. But if a holiday is coming on Thursday, then the number of visitors are increasing. Now, over here, the scenario is that the holidays do not follow any pattern. They can appear suddenly. So let's say you may get 3 to 4 holidays back to back, and then next for couple of months you may not have any holiday. Holiday may be suddenly on Tuesday, or it may be on Wednesday, or any other day. So holidays do not follow any pattern. So it means it's an external factor. So what we will do is we will build the model in two ways. One is without considering the external factors. So I'll not pass any particular value for the holiday, and we will see that probably the model is underperforming. And then once we have that thing, then we will build the second model, and where we'll introduce the holiday factor. So one question might come to people's mind that, okay, holiday, Saturday and Sundays are also holidays, but we don't need to take any care of Saturdays and Sundays because they always follow a pattern. So after every Friday, you will have a Saturday, and then you have a Sunday, and then comes the Monday. So since Saturday and Sundays are coming in a pattern, model or time series model would be able to take care of it. But for the holidays, apart from Saturday and Sunday, we have to use some external factors. So remember your SARIMA X, we have to use a highest model, that is our X model. So let's get started. In interest of saving the time and keeping the video short, what I have done is I have already done the coding in the Jupyter notebook, and I'll explain the code. So prerequisite for this is that people should be aware of pandas, how to read the file. So basic knowledge of pandas should be clear to them. So let me quickly run through the program. So at line number 197, what I'm doing is I'm reading the file restaurant visitors, and then I'm saying index column equal to date. So I'm indexing my date column and pass date equal to true, which means, so there are many columns which might be of your date format. So I'm saying parsing the dates equal to true. So this is how my dataset looks like. Okay. Now, so if you run your tail function, you may see that there are few columns which do not have any value. So NAT, which is not a time or nans kind of thing. So what I'll do is I will drop those values, drop NA when I do drop NA, and after drop NA when I do the sum, this is how my data set looks like. Okay, so now let's do some basic, let's build some basic graphs on this for our understanding. So what do I do? I do a plot over here. So if you notice this plot, the plot is, from this plot we can say that data is neither in uptrend, neither in downtrend, and broadly the data is in we can say that data is almost stationary, leaving few here and there. So some points here and there we might see because of holidays, but broadly the data is stationary. And so over here what I've done is, though it's not much needed, what I've said, RV holiday index equal to 1. So holiday equal to 1. So holiday equal to 1, and then I'm saying index. So I'll get all those dates where the holiday is appearing. And then in this plot, what I am doing is I am plotting the holidays. So if you notice, whenever the holiday is appearing, the values are suddenly going up. It is the same thing which I have explained it from your raw data. So whenever you notice that there was a holiday, you can notice the values were going up. So for example, let's say if I take this Friday the value was 271 and it was a holiday, and compare it with your previous Friday, the value was only 184, and compare it with your next Friday, value is 125. But when it's a holiday, the value suddenly shoots up. So these things you can observe from your raw data, but yes, if you want, you can do the plotting as well. So over here, these red lines, or you can say this slightly the lightish red line, indicates the peak. So wherever the holidays are coming, you get this line, and if you notice, the values are increasing. Okay. Now, so for our more understanding, what I'm doing is I am saying TSA dot seasonal import seasonal decompose, and what is RV, name of my data frame, and total. So let's say, oh, in this data we are already sure that my data is seasonal and seasonality is of time period 7. So let me quickly go through it. So basically, for finding the seasonality, you can look at the raw data itself. Suppose, let me say if I look at this data, so this is 1 week. This is 1 week. So this is the values from Monday. So values start from Monday and then they go till Sunday. So if you notice, within a week the values increase and then they decrease. So values are maximizing towards Saturday and Sunday. And then next Monday, if you notice, the values again decrease. So just by looking at the raw data itself, we can find out that the seasonality period is equal to 7 over here. So you take any 7 days and you will see that the similar pattern is being followed. Keep one thing in mind, if there is some external holidays, the pattern might slightly change, but broader pattern would remain same. So over here, we already know that our seasonality period is 7. But let's say you don't know that what your seasonality period is and you are not much sure. So what you can do is, in that scenario, you can use this function seasonal decompose. In seasonal decompose, you pass your data and this data will give you. So see the third graph, seasonal, and it gives you an idea that your data is seasonal. And then if you look at your raw data, again you can get an idea that the time frame of the seasonality. Okay, now what I'm going to do is, this time I am splitting my data into train and test. So keep one thing in mind, in time series modeling we never do a random sampling, because when we are doing random sampling, any record may randomly become part of my train and any record may randomly become part of my test. So random sampling is not possible in time series. So what do? We do a sequential sampling. So I am taking first 450 records in my train and last few records in my test. Now, whatever, so let's say you don't remember the theory and you are in very haste and you just want to build the model. So what you can do is, and even if you're not in haste, at the end you have to do the same thing, keeping all the theory apart, which is for your understanding. What you have to do is, you have to run your auto ARIMA. From auto ARIMA will give you the values of P, D and Q. You get the values of P, D and Q and you pass it in your SARIMAX, and that's it. You have built the model. So that's the only thing which you have to do. Now what I'm doing is I am importing auto ARIMA. Okay, and ignore the warning. So it gives me a lot of warnings. So I have imported the warnings, action equal to ignore. And then I'm saying rv.total. Rv is the name of your data frame and season. Keep one thing in mind, whenever you are running, whenever you want to find the values of P, D and Q, it is always advisable you do it on your entire data instead of doing it on your train data. Model building would be on your train. But keep one thing in mind, auto ARIMA is not model building. It is only finding the values of P, D and Q. And I say seasonal equal to true and m equal to 7. Why m equal to 7? Because this is mapped to your seasonality period. Suppose you are building a model where the seasonality is of 1 year and the data is monthly. So instead of taking ms7, you will take ms12. So you get the values of these. Now pass these values, pass these same values, or if you want, you may make some slight changes. So I have taken over here order 10, so 100, or if you want, you can take 000 and 1101. So 1017, 1017. Okay, so let me quickly build the model, and then you say model dot fit. Now if you want to do the predictions, do the predictions. So whatever values you get from auto ARIMA, I have passed in my SARIMA. So this was mapped to your first one, and these things are mapped to your seasonal order. Now that's it. So at line number 230, my model has been at line number 230 my model has been I have done the prediction as well. So start equal to 450 and 470. So try giving the same values which you have given in your test data so that you can do the comparison and you can find the errors. Now what I'm doing is I am doing the predictions, and after predictions this. Now so after prediction, what I have done at line number 233, I have said holiday equal to 1. So one second, holiday equal to 1. So basically what I have done is, one second. So now basically I had built another model as well. So what I've done is I have rerun my code. Now if you notice, what at line number 256, what I've done, I have said test RV predicted. And what is this predicted? I am adding a new column, and the values of that new column is coming from your predicted RV. So start equal to 450 and equal to 477. So it will give me the forecasting for those. Now, so if you notice over here, what I have done is I have said test RV holiday equal to 1. So there were 3 holidays in my test data. So I'm getting a data frame only for those 3 records. So if you notice, my actual value is indicated by total and predicted is obviously indicated by the predicted. So if you notice, when it comes to the holidays, the model is underperforming. So actually 221 visitors were there, but I had predicted only 145 and 253, and then I have predicted 174, 140 and 91. Because keep one thing in mind that though I have used the model SARIMA X, but actually the model build is your SARIMA. I haven't passed the values for X. I haven't told anything about the holiday. So if you notice, there is no information regarding the holiday. So the function used is SARIMA X, but the model build is only SARIMA. Now what I'll do is, so I have found the MSC. So MSC on this model. Now what I'll do is I'll find the SARIMA X. For that, what I'm doing is I'm saying auto ARIMA RV total seasonal true M equal to 7 exogenous RV holiday. Okay. RV holiday. What is RV? Name of my data frame, and holiday is the column. Keep one thing in mind. Whenever you are passing the exogenous factor, always pass in double bracket. That's mandatory. Always pass in double bracket, because when you pass in double bracket, the data is taken as a data frame. If you pass it in a single bracket, it is taken as your pandas series, but I want pandas data frame. Okay, because number of external factors can be more than one. So let's say if you have one more factor, you can add and you can say factor, you can have factor 2, factor 3, so on and so forth. Okay, but over here I have just taken, over here we have just one. Now we build the model. So fast forward in time. So model has been created. So when I run my auto ARIMA, I get these values and I pass the same values in my this thing. So train RV order equal to 001. This is mapped to your first one, and seasonal order is mapped to your this one. Or so over here I have taken 10107. So if you want, you can take 2007. Let me build it again. And while building the model also, you have to pass the your holiday, and same thing while doing the prediction, you have to give the information for your holidays. So this is how our values look like. Now when I find the MSC, so MSC comes out to be around 623, and earlier if you notice, the MSC was somewhere around it was little higher probably, so I'm not sure where it has gone, but MSC was 882. So if you notice, the MSC values have come down, which means my model has done less error. Now, so this is how, and this time what I'm doing is I'm attaching a new column, that is a predicted EXOG. So if you notice, this total and this predicted indicates the values without your external factor, and predicted extraneous indicates the values with your X factor. So if you notice, when actual value was 221, SARIMA model has predicted 120, 145, but SARIMA X has predicted 209. And same thing, total was 253, predicted was 175 with SARIMA and 239 with SARIMA X. So when you are building the SARIMA X model, it is able to take care of the external factors. Okay, so that's it in today's video. So at the end, what I just want to recap is, people need to keep two things in mind. Pass the value, use your auto ARIMA. Whatever values you get from your auto ARIMA, use it in your SARIMA X. And then obviously it's not mandatory that you have to exactly take the same values which you get from auto ARIMA. You can obviously change few of them. Few of them, as in what I want to say is that, let's say if you get 0001, so you may try 101 or 1002. Some minor here and there changes are possible. You may compare your model with your MSC or MAP and then decide which combination is giving you the better result. But auto ARIMA will definitely give you a very good point, that which very good idea about the parameters which have to be used. So probably with this I'll end the session. I will end the video. Thank you for watching.